Effects of opiates without causing withdrawal symptoms. Those are types of drugs given to people who are heavily addicted to opiates and can't get off of them, because if they do, the withdrawal might be so bad that they will no longer be able to function. So they can get Suboxone, and it kind of pushes the withdrawal away, still giving your brain the feeling of the opiate, but also blocking the actual action of it, so you don't actually feel the euphoric state, the high that you would get from the opiate. Types of drugs, just two types. Again, this might not be in your notes, so please make a little note of it somewhere, because it could be on one of your quizzes or a test. So an agonist is a drug that occupies receptors and activates them, and an antagonist is a drug that occupies receptors but do not activate them. Antagonists block receptor activation by agonists. Again, there you go. Natural chemicals right here in the green. This is before the drug. An agonist drug, so we have the natural chemical still here in the green, but the agonist is right here. It is taking up the receptor site and it enhances cellular activity. So it actually kind of turns the brain on a little bit. And then the antagonist drug, natural chemical here in the green. Then we have the antagonist drug, which would block this, right, and possibly block cellular activity on the other side in the postsynaptic neuron. All right, let's talk about the nervous system and the endocrine system. That'll be our last thing that we talk about here in our first section. Specialized for communication, up to 1 trillion neurons are linked throughout your body. Right, we have 1 billion neurons in the brain, but 1 trillion neurons packed together via nerve cells and stuff like that. But so organized communication network called the nervous system. That is what makes us go. That's our communication system within the body. The human nervous system is divided into 2 main divisions. We have the central nervous system, which is your brain and your spinal cord, and the peripheral nervous system, which is everything else, right? Anything that's exiting the spinal cord, all those nerves that you would probably understand that would be in your arm, your ulnar nerves, stuff like that, nerves in the leg, all that kind of stuff. So the neuron is the most important transmitter of messages in the central nervous system. Bundles of neurons would be called nerves. So here we go. Nervous system, we just said it, primary internal communication network of the body. Divided up into the central nervous system and the peripheral nervous system. Nerves are bundles of neuron axons that carry information in the peripheral nervous system. Central nervous system, again, brain and spinal cord. Spinal reflexes are things you can't control. If you've ever been to the doctor and kind of understood that this is uncontrollable as long as your leg is relaxed, the doctor could make your knee, you take that little hammer and hit it right below your kneecap and make your leg actually jump out without you even doing anything. That is a spinal reflex. Same thing if you touch something sharp, you could continue to press on that thing and let it, pretty much go inside of your finger somehow. Or you could rely on the spinal reflex. If you touch something that's sharp or hot, your spinal reflex says remove that from that area immediately. So withdrawal reflex is what that is actually called. The peripheral nervous system, so everything outside of the brain and spinal cord. This is kind of divided up into other nervous systems. I'm going to show you a graphic organizer here in a little bit that's really going to help you understand the nervous system a little bit better. The peripheral nervous system, everything outside of the central nervous system, is divided up into 2 things: the somatic nervous system and the autonomic nervous system. So the somatic nervous system is a subdivision of the peripheral nervous system that communicates sensory information to the central nervous system and carries motor messages from the central nervous system to the muscles. This is incoming information and outgoing information. It is handled by the somatic nervous system. Okay? Messages coming in and messages going out. Then we have the autonomic nervous system, which is a part of the peripheral nervous system, but it regulates involuntary functions. Things that you cannot control. You could get better and better at activating or deactivating it. But your autonomic nervous system is flight or fight. That's what we're talking about with the autonomic nervous system. We'll look at exactly what that is here. So the autonomic nervous system is then further divided into two nervous systems. The sympathetic nervous system, branch of the autonomic nervous system that produces rapid physical arousal in response to perceived emergencies or threats. This is fight or flight. It is called the sympathetic nervous system. Does that make sense necessarily? Sympathetic, right? The word on its own, and then fight or flight? No, it doesn't. But sympathetic nervous system, that's what's gonna, this is survival, okay? Some things send you into survival mode, and that is activating the sympathetic nervous system. And then we have the parasympathetic nervous system, the branch of the autonomic nervous system that maintains normal bodily functions and conserves the body's physical resources. This is just being at your state of homeostasis, right? That calm state where your body's just functioning normally, without help, without you being aware of it. It's kind of nice, right? Your autonomic nervous system allows your body to just work on its own, right? Digest things, breathe, all that kind of stuff. So how do I remember the difference between these two things? The sympathetic nervous system is fight or flight. So that's actually being in an airplane and then jumping out of it would activate your fight or flight response, right? So that's how I remember sympathetic nervous system. It is the fight or flight. I'm in the airplane, jumping out of it. And the parasympathetic is a parachute. It's going to bring me back down safely, calmly, to the ground. That state of, ooh, everything's okay, homeostasis. So the parasympathetic, the parachute, is going to bring me safely home. The sympathetic nervous system is going to activate whenever I feel a perceived emergency or threat. So let's look at some of these things here, just a couple. We have the parasympathetics on this side, right, and the sympathetic on this side. I always talk about hide and go seek here. And I know you've probably felt this experience if you've played hide and go seek before in your life. When you are actively looking for a hiding spot, you are activating the sympathetic nervous system. You are in fight or flight at that moment. So, your pupils are dilated to let in more light so you can see more places that you could possibly need to see if you could hide there, right? Your eyes open, right? Your pupils get dilated to allow more light in so you can see perceived threats and also how to escape the perceived threat, your hiding place. And the sympathetic side, again, inhibits saliva production, so your mouth actually becomes drier, right? You don't need that right now. I don't need to break down food in my mouth whenever I'm possibly going to be, dealing with a threat or an emergency because I'm not eating, okay? I don't need to be eating in this moment. It dilates the bronchi, so your lungs, right? Allows more air to come in. It accelerates the heart rate to pump more blood. It stimulates epinephrine and norepinephrine release, so that's kind of adrenaline, right? And then stimulates glucose release, which is going to give you more energy because you get some energy from glucose. And then inhibits stomach, pancreas, and intestines. You don't need to worry about digesting food. Again, you're in a perceived threat at this moment. And this is a funny one that I always think about with hide and go seek. Inhibits urination. When I'm looking for a spot to hide in, I don't have to go urinate. But when I get to that spot and I hide, right? Boom, found my hiding spot. I have to pee immediately. I have to urinate immediately. Because what happens? The parasympathetic system is activated. Okay? We're returning to the calm state. Oh my gosh, I have the sensation that I need to go urinate right now. Why is that? Oh, it's because you found your safe spot. We can chill now, okay? So, you know, it stimulates urination. The parasympathetic does. Stimulates stomach and pancreas and intestines. Digestion can happen again. It slows the heart rate. It constricts the lungs where we don't need to take in enough, as much oxygen because we're, you know, in the safe spot. It stimulates saliva production, beginning the digestive process. And then it constricts the pupil. We don't need to let the light in anymore because we're safe. We don't need to see everything because we're not threatened. Interesting stuff. Here's fight or flight. A lot of things happen to the body whenever you're in it. When sympathetic nervous system activates in humans, tiny muscles in the skin contract, which elevates your hair follicles, producing the familiar sensation of goosebumps. So when you're in fight or flight, yeah, your skin actually reacts as well. And you know, you see it in animals probably more than anything else, right? You see the hair raised on the back of a dog whenever it's either excited because it's about to play. That could also, you know, turn on the fight or flight, or a perceived threat. Here's the human, here's the cat, same thing, you know, fight or flight. This is the infographic that I would study for the test. It puts the entire nervous system in one place and gives great little tiny blurbs of what exactly they would be doing. So central nervous system again, brain, spinal cord, peripheral nervous system, everything else outside of that. It's divided into the somatic, incoming and outgoing messages, and autonomic nervous system controls involuntary bodily functions like whether or not your lungs or eyes are constricted or dilated. So sympathetic nervous system, here we go, fight or flight. Parasympathetic nervous system, let's conserve our energy, we're in homeostasis. The endocrine nervous system is pretty simple. It's your system of glands and hormones in your body. Hormones are another chemical messenger. If you see endocrine system and you see chemical messenger, don't you dare put down neurotransmitter. It has to be a hormone. So like the nervous system, the endocrine system involves the use of chemical messengers to transmit information from one part of the body to another. Although the endocrine system is not part of the nervous system, it interacts with the nervous system in some important ways, just like your immune system would. So hormones are the chemical messengers secreted into the bloodstream, primarily by endocrine glands, and they have a huge effect also on our behaviors. So here's some glands that we can talk about here. So pituitary gland is the one gland that rules them all. It's actually at the base of the brain, right below the hypothalamus. So the endocrine gland, attached to the base of the brain, it secretes hormones that affect the function of other glands, as well as hormones that act directly on physical processes. Like I said, this is the gland that rules all other glands. The adrenal glands are the pair of endocrine glands that are involved in the human stress response. They're located right here on both sides. The adrenal cortex is the outer portion of the adrenal glands. And the adrenal medulla is the inner portion of the adrenal glands, and it secretes epinephrine and norepinephrine, which would be adrenaline. The outer portion here, it actually secretes something else called cortisol, which is the stress hormone. We'll talk about that soon. Gonads are the endocrine glands that secrete hormones that regulate sexual characteristics and reproductive processes. Gonads in women would be ovaries. Gonads in men would be testes. They're huge parts of the endocrine system. A little infographic right here. Check it out if you want to. It goes a little bit more in depth with the thyroid gland possibly. You know, and then pancreas, and then the parathyroid glands right here. I haven't seen it go too far into that on the AP exam, so I don't hit them necessarily. Types of hormones, we have growth hormone. Guess what it does? It causes you to grow. Ask Barry Bonds. You know, Barry Bonds got caught using HGH, that is what it is, human growth hormone. And his head actually grew in size, his bones got bigger, his hands got bigger, everything, you know, I mean, your organs get bigger, muscles get bigger, bones get bigger, everything gets bigger. Human growth hormone, it's released mainly while you sleep when you're young. good rest, good sleep for young people means more HGH is released. Epinephrine, adrenaline, so interchangeable right there. A substance that is released in the body of a person who is feeling a strong emotion, excitement, fear, anger, it will be released. So epinephrine, can be released by, being chased by a bear or falling in love. Yeah, it's kind of interesting, but adrenaline is released on either one of those occasions. Remember, epinephrine and adrenaline are going to be interchangeable for us. It causes the heart to beat faster, it gives the person more energy. Cortisol is the life-sustaining adrenal hormone essential to the maintenance of homeostasis. This is the stress hormone. Cortisol influences, regulates, modulates many of the changes that occur in the body in response to stress, including but not limited to blood sugar levels and anti-inflammatory actions. I've gotten a cortisone shot in my shoulder before because it was extremely inflamed because I tore my rotator cuff. So you get a cortisol shot and it takes care of the inflammation. Cortisone, do you want to be inflamed? Do you want your knees to have inflammation in it when you're running away from a jaguar? And I always say something like that because, again, we're dealing with ancient hardware in a new world. So this cortisol production is really made so you can survive. And cortisol has anti-inflammatory properties. When it's released, you know that you're probably going to be in fight or flight. Yeah, it's the stress hormone. Some people have an overproduction of this, and some people don't have enough. Prolactin is the hormone that stimulates milk production. When pregnancy, birth, all that kind of stuff. Prolactin is this thing that stimulates it. Oxytocin is really called. It also helps in milk production, so it has a letdown reflex. So like the milk is actually let down into the nipple and ready for consumption for a baby. But it's also the love hormone. So oxytocin is something that you get from skin-to-skin contact with somebody else. It can be released just by looking at somebody, who you're attracted to. A person could make you feel love. Maybe that's because they held you as a baby and whatever. Oxytocin is considered the love hormone. So check that out a little bit farther if you want to. Estrogen and testosterone. So estrogen helps control and guide sexual development, including the physical changes associated with puberty, specifically in women. It also influences the course of ovulation and monthly menstrual cycle, lactation after pregnancy, mood regulation, aging process. Testosterone is kind of the same deal, but for males. But it's produced in the testicles, responsible for the proper development of male sexual characteristics. Also important for maintaining muscle bulk, adequate levels of red blood cells, bone growth, a sense of well-being for men, sexual functioning in men. Yeah. These right here, obviously, are going to drive puberty. Okay? All right. We're done. First part, all done.